Hello, and welcome to this Kaeser Compressors Incorporated webinar. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenters. And just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed into the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it, and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenters, Neil Mehltretter and Bill Kemph. As engineering manager, Neil Mehltretter is a key player in Kaeser's technical department with responsibilities including product management, system design, and more. An authority on compressed air assessments, Neil has conducted and supervised thousands of industrial compressed air studies, helping users achieve significant energy savings and operational improvements. He has authored several nationally published articles on compressed air systems optimization and is a frequent presenter on energy efficient system design. In addition to his bachelor's degree in chemical engineering from the University of Florida, Neil is Air Master Plus certified, has completed the DOE Compressed Air Challenge 1 and 2, is a certified energy manager, is a CAGI certified compressed air system specialist, and is a master certified system specialist through Kaeser's factory training program. As project manager for custom engineered solutions, Bill Kemph is a key player in Kaeser's technical department with responsibilities including innovative systems design, project management, construction supervision, quality control, and more. Bill has over 20 years of experience with building, testing, designing, and installing compressed air systems. An authority on compressed air packaging, Bill has designed or supervised the design of countless industrial compressed air package builds, helping users achieve optimal compressed air system utilization and operational improvements. Bill is also highly involved in the implementation of Kaeser's Sigma Air utilities, which typically include extensive site work, electrical, mechanical, piping, and monitoring. Bill attended Spartanburg Methodist College, is MSHA and OSHA certified, and is a Master Certified Systems Specialist through Kaeser's Factory Training Program. Guys, welcome to today's event, and with that, I will pass things along to you to get started.
Great, thanks, Matt. You know, we've seen a lot of equipment rooms over the years between Bill and myself, and institutionally throughout our organization. And from this experience, we can say that the environment can really make all the difference in whether you have a reliable compressed air system or not. Equipment can be tucked into a closet or basement. You name it, we've seen it. And many of these sites experience premature wear and tear, leaving the end user searching for a new vendor. However, maybe it's not the equipment itself, but the location the equipment's in. I like to say changing colors in an equipment room may not change the result. Moving the compressed air equipment to a new location can certainly have that effect. In addition to looking at common problems with equipment rooms, we're also going to talk about the benefits of packaging your compressed air system, as well as comparing the various options, whether it be a skid, a container, or an enclosure. We'll follow up with Bill in regard to some case studies for customers that we've worked with, as well as talk about air as a utility. The biggest problem that we find with compressor room design is bad environment or bad location. Whether, like we're seeing here, with a dusty, dirty environment, or whether it be in a basement, or location that's ingesting pollen directly into the equipment, or the equipment's underneath sorting equipment where debris is falling on that equipment all the time. moving that equipment to a clean, dry area can certainly help increase system reliability, and in many cases can increase efficiency as well. One of the other top items is poor ventilation or no ventilation. What we're looking at here, storage receiver, big white tank that's outside the compressor room, and then you see the compressor room to the right with those double doors. What's missing from this is the louvers and the ducting. So louvers would bring clean, fresh air into the compressor room, and the ducting would remove that hot discharge air from that compressor room. We see none of that. We do see the double doors, so if those doors are closed, we probably have a severe negative pressure in the room as the compressors are trying to suck in all the air it possibly can to keep them cool. Now, the other thing with a room like this that has no ventilation means that we're probably going to be overheating these compressors, and we're going to see severe wear and tear on them, and the lifetime of the equipment is going to be reduced. So we're going to have a little bit more on this particular site a few slides later, but if I told you we had 4 100 horsepower compressors with integral dryers in this room, I hope you would be as concerned as I was that we have no ventilation. Now, certainly at the top of the list is safety. Here we show a mezzanine for a compressor, integral compressor with dryer. It's a 25 horsepower compressor with a small receiver tank. Often floor space is at a premium in facilities, and you might see mezzanines built. Concern, obviously, I would have here is this 25 horsepower compressor with the integral dryer weighs about 15,000 pounds. So you want to make sure that if you're going to build a mezzanine, that it can hold the weight of this equipment. Further, the storage receiver, something goes wrong with the no-loss air drain, that can fill up with water, and now you have a significantly increased load on that mezzanine as well. That's quite a small ladder to come up and check on the compressor from a day-to-day standpoint, so certainly not something recommended. Obviously, you can build a different stairway to that area, but from a service standpoint, all the service for this particular compressor is done from the front, and that doesn't leave you a lot of room to do that service, Plus, if I had to walk up there and look at the screen, I'd be a little bit concerned as well. You probably need follow rest, or if you're going to do service for that, change a motor or an air end on this machine, how are you going to do that? Further in that safety topic, this is on, let's say, dry land, if you would, not in the air. This compressor has the piping coming out, and that piping is resting on an upside-down bucket and cans. The piping's not supported at all either. Plus, the piping is PVC, which is a safety violation. PVC and compressed air don't mix. OSHA's come down and provided guidance on that, so incompatibility. So those are two significant safety issues that I would be concerned with. Also, if your pipe is not supported, let's say this was steel pipe. Now, the pipe should be supported. There's a lot of forces from the compressed air loading and unloading or starting and stopping, and that movement of air through the pipe can have some significant effects, especially if it's not braced. Further, any flammable or hazards would not be recommended to be located near your compressed air system. That small little room we talked about with the 400 horsepower compressors, here's another view of that room. Inadequate space for service. We talked about this already with that mezzanine, but it's the same thing. Service access is from the front of this 100 horsepower integral dryer compressor, and those doors swing open. I like to joke with my kids, you're lucky your father's not humongous. He can get in these small spaces in this vehicle. It's the same thing here. You're not going to be able to service the equipment in an easy way in this particular facility, in addition to the fact that you have zero or limited ventilation as well. So further, you want to make sure that your electrical cabinet can open fully and that there's space for you to move around it should any issue arise. So getting back to not just adequate space for service, but safety as well. And we see this often with compressor rooms. They tend to, maybe they're a little bit larger than they need to be. Most cases they're not. But excess items from the facility end up in that compressor room, whether it be product or construction equipment. It's not recommended to use your equipment room for additional storage. These particular compressors happen to be on casters, and while the casters are lockable, it's always recommended to keep your equipment in the same place. And we'll see that a little bit later with the package systems on how you can mount the equipment. In general, when companies are ready to expand, most equipment rooms are already full, or they suffer from one of the ailments that we just mentioned. Companies may also want to reclaim their compressor room for production. So how can we go about doing that? A rhetorical question there, obviously. Package systems are very advantageous when it comes to this. In many cases, placing a package system outside of the facility requires limited or no permitting. If the plant were to build a new equipment room, certainly permits would need to be pulled, site preparation would be required, and the process could take months or years. With a package system, these can be built to meet very specific needs: airflow, pressure, air quality, and most importantly, physical size. Another great benefit of package systems is portability. So we see here some rigging putting a package down outside of a facility. This is also the same for compressors that were in that small little white building with the big white tank outside. After talking with the customer, we convinced them that it wasn't good from a long-term standpoint to keep these compressors in that area. They agreed and shipped those pieces of equipment to us, and they were packaged in this enclosure that you see. In the top left, that's the inlet air, so all the bank of louvers there for the 4 compressors. And then down on the bottom right, you can see where those small ducts over what looks like doors, that's the hot discharge air. So different sides of the packages. Those doors are actually service doors, so that you can do the service from outside the equipment. Nice part here is, plug-in pressure. It's just that simple. I mentioned that size does play a big role in package design, whether it's one particular piece of equipment or it's multiple packages. They can be designed modular in pods, like we're seeing here at this installation. So, bottom line, you can start small, and as your capacity increases and your facility expands, you can add these pods one by one. Remote locations, another great application for a packaged piece of equipment, whether it's like we're showing here at a rail yard, or we'll see later on with a natural gas pumping station. The time-saving aspect of dropping a package in, ready to provide compressed air or vacuum, can keep your production running smoothly with little or no downtime. So why move out? So before I hand this over to Bill for some case studies and some other key points to look at when you're considering package systems, recapping why plants decide to move industrial air equipment outside a facility. Remember about those bad environments or bad equipment rooms, and the main issues were environment, ventilation, safety, and service access. Many plants just simply want to use that space to expand production, and maybe putting in a new equipment room is going to be costly from a time and money standpoint. Package systems allow facilities to scale up and fast to meet expanding needs. And lastly, portability. There are some applications that require equipment to be moved from place to place, or that ships with other larger production equipment and therefore needs to be modular for ease of installation. So a lot of good examples or reasons to package a system. You know, we've been designing package systems for a fairly long time in the industries, and the applications, they vary widely. And while we tend to see some packages repeated, which is always nice, the great part is that these pieces are interchangeable and they can be designed from the ground up, whether it be plant air, instrument air, process air, and even breathing air applications. Plus, these types of packages are available for industrial vacuum, for rotary screw blowers or rotary low blowers, as well as booster compressors. So, you know, there's a lot of applications out there that work very well with this type of design. The installation, startup, and commissioning benefits can leave the owners and operators feeling relaxed about their industrial air needs. Since the components have been assembled and tested prior to leaving the factory, the package system just needs to be set, piped, and powered, allowing for faster and simpler integration. Plus, because all the ventilation, electrical, and piping for the equipment has already been completed, this generally means that we either need less contractors or their work on site is much less. Putting up a building to house industrial air equipment, that can be expensive and can take months or years. Further, in many locales, package systems may not need permitting. Now that we've looked on the outside of these packages, I'm going to turn it over to Bill so we can look at the details on what you'd expect inside.
Thank you, Neil, for sharing all that valuable information. So let's go back and now let's discuss the internal aspects and the different benefits that is obtained through a package system. One of the main points is the simplicity or the single point connection. And here I'm referring to the electrical power connection, whereas a single electrical service would be provided, and also a single piping connection would be provided. This allows for a quick installation. All items are properly sized, and thus speeding up the production line to facilitate its completion. In designing one of these packages, besides ease of installation, we also concentrate on the safety aspect. And this is how, in regard how the equipment is placed, the service spacing required, and such. With this, certain codes or compliances need to be considered. First and foremost is NEC, or the National Electric Code. And I'm referring to the electrical spacing in front of all power distribution panels or control cabinets. Another one is OSHA, and that is in regard to the minimum clearance of walkways or the number and location of access doors. Another benefit is controlling the environment. With a properly designed and sized package that includes a properly sized exhaust duct, we are able to evacuate all of that heated generation exhaust, and therefore we can regulate the internal temperatures of the room. This is imperative when designing a compressor room, because this is usually your pass or fail with the temperature-related items. So now we're talking about general operation benefits. With an enclosed package that is placed outside a plant, this serves many benefits that the customer may not be aware of initially. With a plant or a package that is placed outside of the plant, there's no need for service personnel to enter a plant. This can be a great security benefit, or even if there is a proprietary process that is involved, that the customer needs to keep under wrap. When it comes to in-house safety or in-plant safety items, by placing a package outside, we are removing certain hazards, whether it be electrical or that rotating equipment. An additional benefit is remote monitoring. Now that a package is placed outside, it is much easily accessible for cell service coverage or such, whatever device is used to monitor the package. Therefore, preventative maintenance, repairs, and audits can be performed. In my opinion, one of the biggest misconceptions that engineers, customers, and such have is operating temperature. This is one of the most important factors. This needs to be determined up front in a design phase. We need to know, or you want to express the lowest possible ambient condition possible, and of course the highest ambient condition possible. Therefore, the package can be properly designed. The proper amount of insulation can be installed. Supplemental conditioning for air can be provided, or auxiliary heating can be increased. Then we come to meeting specific requirements. As we grow more and businesses get larger, they all tend to have varying and different requirements. With a package system, and being that it is constructed from the ground up, we can accommodate a wide variety of components or accessories. Some of those can be a fire detection system with alarm. It can also include emergency lighting, specific instrumentation, special connections, and we can meet a wide variety of piping needs. Here you'll see in the upper left picture, you'll see some cross bracing, which was the result of a seismic zone requirement for a particular installation in a locale somewhere in the United States. Packages built as such can be reinforced and designed to meet those specific requirements. It is imperative that the information is provided up front and that all possible avenues are explored. Verification of this information can be provided through proper stamped drawings. You can see in the lower left an example when it comes to machine mounting feet, how to properly, or an example of how to properly anchor a piece of equipment to a steel structure or skid. You can see on the right where is what we typically would see in the field. We would see the compressor just placed in a shipping container and no precautions or preventative measures kept to keep the unit from moving. Another specific requirement that comes to play quite often is witness testing or factory acceptance testing. This is the validation, the verification that the specified item meets or exceeds the customer's requirements. And of course, documentation, documentation, documentation. This is the backbone behind all applications, is proper documentation. There's several weather-related loads that need to be considered whenever we are designing packages. One would be the applicable wind load. Throughout the country, the different locales all have different and varying wind ratings that buildings or packages or equipment must meet. These are all factors that can be built into a design of a package system. Like I mentioned previous, it is imperative that it is known up front. If you lived in the, say, the North Atlantic, it would be an important factor to have an increased snow load. These are all possible within a packaged compressed air system. If you lived in the Midwest, it may be a concern that the fear for installing lightning arrest equipment. These are all options that are available for these kinds of packages. And of course, do I need to even speak or discuss pollen and dust? Everybody, everywhere has this issue. Preventative measures can be installed, pre-filters, whether they're removable, self-cleaning, and such, to remedy this. These always come at a cost, and it's usually airflow, so this needs to be considered in the design. So let's compare some different options when we come to package systems. First and foremost is a skid. A skid package is for indoor use. The benefit of that is it's relocatable, and it has an ease of installation. A shipping container. I am referring to an ISO shipping container that is modified. An ISO shipping container does have its benefits when it comes to being more robust, but it does have its limitations in regard to flexibility of service space. It does provide a greater benefit for, we'll say, a rental application where the package is relocated more frequently and the possibilities of damage is more involved. Then last but not least, we have an enclosed weatherproof enclosure. A weatherproof enclosure, these are the most flexible as they are built and designed from the ground up. They can accommodate a wide variety of equipment. And basically, the only design limitation for this package is to be able to transport it down the road. There are many applications that involve special locations with different requirements or dangerous requirements. Here's an example of a natural gas pumping station. The compressed air needed to be utilized in the hazardous zone or a class zone. However, with a compressed air package as such, this package can be placed on the outside or the perimeter of the hazardous location and the compressed air piped in for use. For instance, this package had a very detailed specification, design, and such. It was to be an unmanned operation and controlled remotely. And it also had to deal with the high heat of the desert, so high temperature extremes. You can also note some of the options or benefits that I spoke about earlier. You can see the package is equipped with a single outlet connection for the piping. However, it does have another plumbed-in connection for a rental, as well as a condensate connection. Here's another example of a grocery distribution facility. One of the main benefits this customer was able to achieve is that they were able to gain valuable floor space within their warehouse. They were able to take that electrical rotating equipment and place it outside in a safe and secure housing. If they ever chose to expand in the future, it was a simple crane rental and a relocation. This package was also equipped with an external disconnect. As Neil mentioned earlier, the side that we are seeing from this is the exhaust side. The dampers shown are the exhaust side, and the panels that are below those are for major service or removal of the individual compressors. The intakes would then be placed against the building, so we do not have any recirculation of heat back into the package. Here's an example of a skid package. The main principle here was to minimize footprint. The customer also wanted a complete package, portable, and all the conveniences of single-point connection. By having a skid package, it also ensured that the system was installed properly. The correct filter was placed in the correct place, and the correct piping or other components were utilized, as the package that is being shown was a booster application. Here is an example of an enclosure for a wastewater treatment plant. Just like screw compressors, as we have talked about previously, wastewater treatment plants can have the same benefit from having such enclosures. The one in particular had a high temperature fluctuations. It was up north, therefore we had to accommodate for high snow loads. And of course, the single point connection. You can see the unit is equipped with, it's placed on a concrete pad. However, it is not necessary that it is placed on a concrete pad. They can be placed on a solid, hard-packed surface, whether it be gravel, asphalt, or concrete. It can be placed on piers. However, we would prefer to know this up front, or it's best to let your design team know this up front so they can build in any provisions that may need to be discussed. So let's take a look inside the wastewater treatment package, for example. The package are a great fit for the wastewater treatment field in consideration for lobe, screw, or your turbo blowers. They come equipped with electrical distribution panel, complete with individual breaker or a fuse disconnect for isolation of the equipment within. Thermostatically controlled fans control the indoor ventilation for such packages. They have a digital thermostat and have a remote sensor that can be placed in the package to reap the best benefit. In our colder temperatures, when the unit is not running, to maintain an indoor ambient temperature, standalone heaters are provided. These heaters are electric, self-contained, and self-controllable. They come in a wide variety of wattages for their individual power supplies. The enclosure itself is a structural steel framed member. It has a supporting structural base, and it has an aluminum skinned outer. This provides the most longevity possible in a package, as the unit is basically maintenance free. The interior walls are comprised of sound dampening material as well as a thermal barrier. This incorporates or comprises together to emit very low external sound levels. The thickness of the walls is dictated by the extremes of the weather conditions. Ample access doors should and are provided to allow for proper service, exit means, and entrance into the package. The intake or the inlet volume is controlled through thermostatically controlled louvers. The louvers have a main benefit is a proportional actuator. This actuator, being proportional, allows the signal to vary, thus varying the position of the damper blades at any moment in time. Therefore, we can maintain a constant temperature and do not have large fluctuations within the package. Here's an example of a skid. This was a very large package, and it had to be comprised of two skids. One was the compressed air side, and the one on the left is the air treatment. The customer was a distiller that was not very familiar with the installation of compressed air equipment, nor did they have the proper means of support in their area from the various different trades. So they asked for a package that was the easiest for installation. This includes the piping, the electrical, and the condensate. It's provided with the single point electrical connection, and on this particular package it had a separate air receiver tank, so you can see that there was multiple connections provided for that. Here's another example, which was an instrument air package for a wastewater treatment plant. It had a very detailed specification. You can see the exterior is standard aluminum skin, unpainted per spec, and it had a wide variety of controls within. It also had the ability to have witness testing. Therefore, the customer could validate and verify that the package that they purchased was built to spec. And of course, documentation. So let's take another look on the inside of one of our package systems here. This one in particular is an enclosed one. There's a wide variety of air treatment that can be installed. For example, what's showing here is a refrigerated dryer. Now, when it comes to piping, Kaeser standard is aluminum piping. However, we can explore, and there is a vast array of different pipe types that are possible for the customer, whether it be your carbon steel, which we do not recommend, or your stainless steel. They can be the threaded or the welded version. Last but not least, we have to bring up the station controller, the master controller, as this is the heart of the package, and it allows the package to run in a seamless manner. It improves pressure stability. It allows for continuous fine-tuning of the package, and it allows for remote communication if required. Now, I thank you for your attention, and I'm going to pass it back over to Neil.
All right, thanks, Bill. I always enjoy this. There's a lot of information there, and stuff that I should know, but it's always good to see it again out there and share the information. Our last topic is air as a utility, and this simply means that you're outsourcing your industrial air system to a third party. The benefits of air as a utility can be the same as your packaged systems. Simpler, faster integration and commissioning, reducing or eliminating the permitting process, saving on new construction, and gaining needed space in your facility. Air utilities are different than a service contract, as the end user doesn't own the equipment. It's owned by a third party. They design the system per the end user specifications. That third party then services the equipment and ensures uptime by including redundancy, as well as not just for your compressors, but also for your air treatment if it's a compressed air system. And the end user pays a predictable monthly bill. So that's something nice that we can all appreciate. With air utilities, the primary benefit is that there's no capital outlay for the equipment. That money can be used elsewhere, or if that money to procure new equipment was going to be used for your to go against your bottom line, then it does create some interesting accounting perspectives. Air utilities allow facilities to focus on their core business and allows maintenance personnel to shift their responsibilities from managing this industrial air equipment to simply checking in. Air utilities should be monitored 24/7. Master controllers, like Bill mentioned earlier, they're going to manage that equipment operation, select the most appropriate equipment to meet current needs, and balance the service hours to minimize service trips by the provider. But in addition, alarms and warnings are going to be monitored continuously, and service personnel can be dispatched should the need arise. Lastly, reporting should be submitted on a monthly basis, and that's going to provide needed visibility to key plant personnel so that they know what's going on with their industrial air equipment. So in summary, compressed air, it's expensive to purchase and to maintain. And we looked at multiple issues within a compressor room that can arise either right off the bat or that can creep up on you over time, years after your installation. While many of these equipment room issues can be solved by packaging that equipment and moving it somewhere else, such offerings can solve many other problems as well. While there are many vendors out there, make sure that your provider, if you're looking at a package system, make sure that provider understands all the necessary codes and requirements for your industrial air equipment. And finally, there are a lot of providers that are out there that can offer air as a utility, just like electricity. So that could be advantageous to your bottom line. So definitely recommended for those folks who are interested to look into that as well. All right, well, that wraps up our let's say, formal portion of the webinar, and we're going to go back to Matt for some Q&A.
All right, great, thanks. And thanks a lot for that great presentation, guys. Well done. Now let's get to the Q&A. We have some questions in the queue that came from the audience, so we're going to move into answering those now. And I'd just like to take this opportunity to again remind the audience, if you haven't submitted your question yet, you can do so now by entering it in the Q&A box and clicking submit. We'll try to answer it before the close of the session. Okay, now for our first question. Since those solutions are outside my plant, how can I observe proper operation and possible maintenance requirements without having to send somebody out there? Guys?
Yeah, that's a great question. That really keys into that master controller that Bill mentioned and I also talked about there at the end. Many master controllers that are out there and even individual controllers for your industrial air equipment can push information, whether it be alarms or messages, or could be seen via web, via a website, so that you can look and you're seeing basically the same screens that you would see at the equipment. So, either that could be available via Ethernet, or, if you're looking for industrial protocol, if it's Modbus, if it's Ethernet IP, those things, there's a lot of seamless integration that's out there that may require you to do a little bit of work on your part, but if you've already got a DCS or SCADA system that you're trying to push information to, many of these things are available. So, yeah, it really can be right at your fingertips. If using those methods don't work, Bill also mentioned that you can also put this through via a modem and cellular service. So there's some options there as well.
Great, thanks for that. Okay, and now for our next. How do you handle minimum intake air temperature requirements? Do you limit these solutions to warmer regions?
Yeah, that's a great question. So I'm going to rephrase it a little bit and just say, if let's say you're in Canada versus you're in Florida, your operating temperatures, ambient temperature is going to be vastly different. So what I didn't mention, which is probably in my speaker notes, but I just sloughed right over it, is that when it comes to compressors or compressed air, they're very efficient heaters. And a lot of that energy that you're putting into it, almost all of that energy you're putting into it, can be reused in regard to waste heat. So, your question is, am I limited to, maybe middle of the country before it ices over? And the answer is no. A lot of these package systems can go down, maybe even below freezing, and the reason is twofold. Number one is it's the package itself. Bill mentioned about the insulation that's in the package, and so, if it's a container or enclosure, you can put more insulation, make those walls thicker so that you can maintain the temperature inside the package better. And then secondly, to getting to my very efficient heater bit, and Bill mentioned about inlet louvers and temperature control. It's the same for the outlet louvers. Most packages that we build, for example, has a recirculation effect in it. And so the idea is that you're measuring the temperature inside the room and you want to keep it a nice cozy 68 while the temperature outside is minus 10. And the way to do that is, once the compressors are running and loaded, you've got a lot of heat buildup, and instead of pushing it outside, you're pushing it back into the room, and then that's mixing with some of the quote-unquote fresh air from outside, and that's how you're maintaining your package temperature. So you got anything to add?
No, that was a very good description of the processes. Depending on the size of the unit, you may want to consider the zone effect. You may have one that has one where the unit is setting still on one end of the package. So there's a wide variety of the different aspects and ways you can look at it. So, no, that was a good response. Good question, too.
Excellent. Thanks, guys. Okay. Just want to take this time to again remind the audience we are in the Q&A session now. So if you have a question, please send it in. Okay. Now for our next question. Are the package systems fire rated?
So, as standard, the packages are not fire rated, and the main reason behind that is the package itself, the weatherproof enclosure, is not comprised of any materials that acts as an accelerant that would thus require a fire rating. The material is steel. The insulation material is typically a mineral wool and stuff like that. So the package itself is not considered to be, it can be if the specification allows or requires it to have a fire rating to it. However, the cost would be, need to be added to the package. But however, 9 times out of 10, there is not a need for this to be explored.
Excellent. Thank you for that. Okay, now for our next question. Is it possible to tie in the equipment to an existing BAS?
Yeah, absolutely. You know, it kind of gets to the first question that we answered. You know, if you do have a master controller that's in this package, you know, typically those master controllers have various outputs, even discrete outputs. But you know, push information, Modbus, Ethernet IP, you know, even OPC UA. You know, it depends on what methodology you're using to get the information, but certainly it is available.
Excellent. Thanks for that. And I just want to remind the audience we have about 10 more minutes, so please send in your questions while the experts are with us online. Okay, next question. What do you recommend for Class 1 Division 1 situations? Yeah, so that's a great question. You know, in general, the rotating equipment, you know, if you're going to put that in a Class 1 Div 1, then there's going to be very specific things that you would have to do. You know, the recommendation that we necessarily would have, or that you could do, is if you're outside that area, then you pull the pipe in from outside the area to whatever use it might be. So that's the way that we've tended to handle it. And you know, I know there's some packagers out there that could certainly provide an entire package, a Class 1 Div 1. That's not the way we've handled it. And you know, the reason is it allows us to offer standard equipment and a standard package, which provides a fairly straightforward pricing, if you would. And then, you know, there is the added cost of running longer pipe to wherever it is that you're going, but it does also allow for, you know, easy service access as well to that equipment. A good question. Great, thank you. We still have time for a few more questions. Okay, here's one from the audience. We have to put our compressors in rooms that can handle a 1-hour fire test in case of an issue for insurance purposes. Could we get it fire rated that way?
Yes, you could. And like I mentioned earlier, that would be part of the specification build. Those details would have to be provided. In other words, the rating, the duration, and certificates could then be provided. So the answer is yes. It's not a standard feature. It is special request. So everything is, many options are available. However, they do come with a specialized cost. The ultimate goal here is to try to make the package affordable to the customer, but where it is needed, things can be adapted.
Great, thanks for that. And it looks like we have one last question. Can I simply connect it to my Ethernet company network?
You know, it obviously depends on the package itself, but you know, most master controllers or individual controllers have the ability to push information via web server, via Ethernet. So, you know, certainly I know ours does, and that's easily available. And the great part about that, like I mentioned earlier, is you're seeing almost exactly, if not the same screens that you're seeing when you're in front of the equipment. Obviously, the only difference with Ethernet is you can't change anything, but it gives you a nice ability to kind of, you know, I'd say babysit or, you know, watch from afar how everything's going. So, you know, if that's part of, you know, what you do every day, from stop in the compressor room and check what's going on, you can do that remotely via this Ethernet. We've also had some customers ask for video input into the package system. So, you know, you look on one Ethernet connection, you look at what the master controller or the individual controllers are doing, and on the other web browser you've got the video feed. So it makes it a nice kind of closed book in regard to what's going on in that compressor room or industrial air equipment, whether it be blowers, boosters, etc.
Excellent, thanks for that. And it looks like we're going to wrap things up right there. So guys, thanks again for taking the time to be with us today and taking the time to answer some questions from the audience as well. I'd like to also thank the audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. Lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find it located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.